This
I am
conference will
Steve.
now be recorded.
I am
Hey, Peter.
Steve. How you doing?
Good.
Doing well.
All right, so we'll go ahead and, Kaylee, is there an easy way to take roll?
Yeah, do you want me to just note down everyone, or do you want me to go through and let everyone introduce themselves? How would you prefer?
Let's do 10-second introductions, just to make sure that we kind of have an idea who's here.
Okay, I'm gonna say everyone's name, and then when I say your name, can you give a little bit about yourself? That way people aren't trying to speak at the same time. So Stephen, do you want to just mention how you're the project lead?
The project lead for OCP.
Okay, David Ellison.
Hi, I'm David Ellison from Lenovo. I'm a senior artificial intelligence data scientist, relatively new here to the OPC community, so I'm just here to learn and listen.
Awesome. Pete Hopton.
I am Pete Hopton. I'm the founder of Isotope, but also heavily involved in the EuraExa project.
Joe Foster.
Hi, this is Joe Foster. I'm a architect for Microsemi, and this is my first time calling in. Just again, as the earlier person mentioned, listening and learning.
Mark Kelly.
Hi, I'm an embedded engineer at Isotope. I work for Peter.
Nigel Gore.
Nigel Gore, head of product for Isotope, interested party in seeing development of OpenBMC for HPC systems with the Open Compute project.
And I think that's it, Stephen.
All right, that's a good place to start. So, gentlemen, thank you for the call today. We're taking this call as part of the overall process to start adopting the commitment process towards divulging IP into the open compute infrastructure. And one of those steps is to have this meeting and discuss it with the project team and to clarify that, and then for the project's leads to take the next steps with the contributors to make sure that it gets marshaled through the process efficiently. So with that context in mind, the agenda, I'll go ahead and list it out here and allow you guys to make some comments, and then we'll start to iterate through it. One of the things that we want to do as a first part is talk about the vision that the Isotope team has for these products and what you'd like to, where you'd like to go with this. And that could be the endpoints here are going to either be simply the OpenBMC tree updates, or hopefully a OCP type of product where we are able to turn around and take some of the Isotope technology and declare it OCP compliant, and then allow the OCP channels to help the situation and help the product delivery to the field. And then there's another, to have a OCP specification such that we could distill basically an abstract specification from the proposed offering, so that we could allow for a broader adoption of the technology and label and allow other people to label their products if they comply as either OCP inspired or OCP conformant, right? So we need to it would be good to share the vision first and get that documented. Be prepared to do that. We want to discuss the community goals, with respect to what we think is best for the community here. Make sure that we have the IP clarified and that the IP contributions to the community are clearly delineated from the product IP. Then go back and identify the key design parameters, acknowledge the process. So by the time we end the call, I'll go over what's on the website for the process and make a commitment to helping you guys marshal through. And then before we close, I'd also like to understand Isotope's timeline so that we can put between Adi and I put the right attention towards helping this out. This will be as a project lead for Adi and I. This may be the first thing that we marshal through, and we want to make sure that we give you the best support that we can. So is that what align with what you guys were thinking, Peter, Nigel?
So we're very interested in learning more about OCP, this process, how we could have our technology certified as compliant to support other OCP things. We're not at this point authorized to commit stuff to the project except for the Open BMC. So I thought this was a good trailblazer. But Nigel and I are both very interested in learning more about the OCP process and how we can better interact with OCP.
Okay, so I think you've taken the first step here. Saying, if I remember, this is called the Zinc OCP or Open BMC. Sorry, is that the particular piece of that you're thinking about contributing?
Well, so the Open BMC thing we did was we've ported it to a new chip and a new architecture. So yes, that's what we want to contribute. But there's some debate whether this is still covered under OCP or whether it's now part of the Linux Foundation. But either way, we'd very much like to tell you about the work we've done and see if it's useful.
Yeah, I think
So
what might be interesting is to just kind of like say, explore what it is and kind of what kind of newness that it brings in terms of, does it bring some newness to the hardware itself? And I think that's one way to explore whether ultimately it lands in the Linux Foundation and OpenBMC project scope, or does it land here, or does it land in both places, or something like that. I think it might be just interesting to understand how it actually impacts. If more people pick it up, who would it impact? That would be a good, I think, tech. Yeah.
And I think that the ability to have it, I guess from what I know of this, my vision would be that the contributions in the GitHub, the actual contributions would end up, of course, with the OpenBMC project and the Linux Foundation. However, if we distill the specification or the API that you used for the control system, the unique things to do the liquid cooling, implement the liquid cooling design control system, that we could abstract out in terms of have an API definition or whatnot, and then put that into as an open compute specification, and that would allow you to then exercise or set a standard for the community here, and then allow the product ultimately to be either OCP inspired or carry the label as an OCP product, because you would of course support more or less by construction that specification, and we would allow the community to take a look at that specification and say, hey guys, this is where we think you got it right. Maybe for openness, some other people interested would want to expand it a little bit, but ultimately we would take that through, and that would be a product of this group. So I think so that was my vision. I think Adi said I turn Peter, back to you.
Well, at this point, I just think I've spoken a bit for Isotope. Be interesting to hear what Nigel has to add there, and then we'll hear from Mark to tell you what we've done basically. But Nigel, anything to add at this point? Have your phone on mute, Nigel?
And I had said such a great piece of work. Unfortunately, I was on mute. Good. Look, all around, agree with what's being said. We want to make sure we can basically contribute in the most appropriate way towards this HPC program for open compute. A lot of experience that we've got through the European Union project that we're working on, and there is an OCP variant that we use in terms of form factor. So just making sure we're navigating through and understanding exactly how and best to contribute. So we are still learning on this side. So it is a learning curve for us.
Cool. And Stephen, you know, I think the idea around APIs and standards for interaction is very interesting, because at the moment I don't think normally within a data center, cooling is considered part of the building management, isn't it, rather than part of the server management. I think ultimately those two are going to have to start to become one as more and more cooling comes into the server and more building related activities become part of the cabinet, as we've already seen with OCP. So, you know, some useful thoughts there. So thanks for that. So, Mark, can we make you the presenter? Callie, I think, would do that. Excellent.
Yes, Mark, you should see your screen. You should see something pop up on your screen, Mark.
Yeah, I can see that. So hopefully I'm sharing my screen.
Yes.
Yeah, so my name is Mark Kelly. I work with Peter on the EuroExa and exascale projects, which is sort of pathfinders towards exascale computing. And these machines are all going to be sort of liquid cooled due to the size and power density of them. So we've been doing some work on a management system in order to control these kind of systems, and sort of as an open source solution, OpenBMC and its variants sort of fit the bill pretty well. So a bit of background on the exascale itself. It's an FPGA CPU hybrid architecture currently, very high density. So you have multiple boards all inside a one OpenU chassis, lots of FPGAs, very high power densities, very high compute densities, sort of upwards of 3 kilowatts in a single chassis needing to be cooled. And you can't leave this to chance, because the sort of the power levels in terms of the power supplies, the currents, the temperatures, they're all at points where you really do need to know if things are going out of spec. And so you need to have a really good sort of board management system controlling this. And the complication is that it's 16 individual computers rather than a single system. So you want your board management system to be aware of the fact that there are 16 individual systems all running independently. You've also got communications issues. So you have lots of serial ports, you have lots of networking, you have FPGAs with JTAG. All this is liquid cooled, so you can't just sort of open it up and attach things to it. You've got to control all the power supplies, the pumps. You've got to monitor the voltage, the temperatures, the actual coolant quality, the coolant level, and things like that. Being as it's a kind of R&D project still, the architectures change their mind quite quickly, and so you need to be able to adapt to new designs really quick, which is where our approach has kind of paid dividends and been a quite useful one. So rather than sort of the traditional BMC, which is a kind of simple system on chip processor, kind of usually it's an A-speed based device, we've taken a different track, and we've gone for an FPGA based BMC using Xilinx's Zinc systems. So you get a dual ARM core and a load of reconfigurable logic, where you can basically do what you want above the kind of standard interfaces that the ARM core provides. We've had this running on thermal validation test vehicles, started with a bare metal operating system, moved to a FreeRTOS system with network control, and now it's moved to a kind of more BMC standard system. And when we were looking for this, there's kind of two OpenBMC projects. There's the OpenBMC project, kind of the official Linux Foundation one, and then there's also the OpenBMC project that Facebook hosts on GitHub. And from our point of view, initially we chose the Facebook one. In all honesty, the main reason was it was easy to get started with. It has less in it in terms of server architectures.
And the multi-node part, yeah.
Yeah, and that was the main problem. We had 16 individual nodes, and Facebook had a reference design for a 4-node server, which was a good starting point to figure out how do you control a multi-node system. But having said that, most of the work, because it sits at a kind of high application level layer, you could port that to the Linux Foundation OpenBMC project without too much problem. The lower level stuff, the hardware drivers, the specific Linux kernel driver for the Zinc, the drivers for all our custom sensors, again, because that's independent at a very low level, that can port over as well, because that's part of the Linux kernel and the fundamental Yocto BMC kind of low level stuff. Xilinx actually provide a really good Yocto layer. So we basically just pulled that layer in. You pull that layer in, you set up your own extra configuration bits. FPGAs bring their own interesting mix to it in terms of you have to load the FPGA image in as well as U-boot and such things, but the tools exist to do this reasonably self-contained without too much trouble. So we basically just added our own layers to the existing Yocto setup that existed for the XNest system. And inside the XNest system, we actually have two kind of prototypes in progress. There's the initial one, which used the Micro Z, which is kind of a baby FPGA with a simple dual core sort of standard 32-bit ARM processor in. And then there's a Track 2 XNest and EuroXA project, which is, because it's a much bigger system with the full 16 nodes, we've moved to the Ultra Z, which gives you a lot more logic space, has a lot more power. It's a 64-bit CPU inside the FPGA, and you also get lots of other nice features. That's currently still work in progress. The Micro Z based system has been used. We've had that running on thermal test vehicles, and we've had it running testing, doing network testing with existing processor modules as well. Sort of the way we've got it sorted out is that the U-boot basically just pulls a single image in, which contains the operating system, the RAM disk, the device tree, and most importantly, the sort of the FPGA bit stream. It pulls all this from QSPI, flashes the system, and then boots it. So you go from 0 to fully loaded running Linux with the FPGA programmed in about 7 to 8 seconds. The processor itself is a dual core ARM as a minimum, so you get a fair amount of sort of processor horsepower from this. But the main use is the logic. Our system, the sort of the Track 2 system, is going to have 32 serial ports in it. So we just have the FPGA logic deal with all this serial data. It also has JTAG, so there's Ethernet to JTAG, things like that, which again, we just plonk it into the FPGA and it gets handled quite easily. But it allows us to change things really quickly. So if you want to change what drivers are in, it's literally a case of inside the FPGA tools, placing new IP, rebuild the operating system at a top level, just change the applications to use the new drivers. So adding ICE with C ports is pretty easy. You can just add as many as you want. Adding PWM drivers, adding SPI drivers. You can pretty much do, and if you could do it in an FPGA, you could pretty much add it to this BMC without having to put too much extra logic on the main board. And because the BMC itself is a plug-in module, you don't have to actually place and route quite a complicated FPGA. So the Track 2 prototype will be using this more complicated Xilinx UltraZync, and this will be quite a complicated, controlling 16 full nodes, monitoring power to all 16 nodes, monitoring main power, also talking to another big FPGA switch that's on board. There'll be a lot more sensors because the power levels inside the server are a lot higher. Cooling is critical, so we'll be monitoring the cooling with coolant level sensors, coolant temperature sensors, pump sensors, pretty much anything that can be monitored will be
So,
ending up.
no, this is brilliant. So this is good. And when you say this, the track two, you have, smaller FPGAs collect some information, and an FPGA switch essentially. Does it mean that you have one on each node? Something like that?
There's a big selection of sort of I squared C sensors spread about on the nodes and also on the carrier card
Right.
around the system. And then also you can talk I squared C. The FPGAs themselves have built-in system monitors, which run I squared C buses. So you have a very complicated I squared C bus fan out. I think the current has something like 32 software I squared C buses going out to everything. But of course, all the multiplexing is handled quite easily by Linux. The standard drivers just handle it. So from a software application point of view, it's a case of just reading a file in sysfs and you get the hardware numbers. And the BMC deals with all the I squared C interfaces in hardware. The software just sees different drivers, different endpoints, and things like that. But we can also...
Mark, I think one thing to clarify here is the topology, because obviously we have FPGAs and FPGAs and FPGAs. So what we have is daughter cards, which are the nodes. They have a load of FPGAs on them, but not a BMC. The FPGAs on those are for doing the compute. Then we have a carrier that has a network switch on it that's a big FPGA at this time. That's for doing the network switching. And on the front of the carrier is one of these devices, which is the BMC for all 16 nodes and the network switch.
Interesting. That gives me a little bit of color, and that makes sense. I mean, why you would do it that way. Something that I'm also interested in it as a follow-up is, especially, I've played around with just a chip that has bunch of ARM cores, or a chip that has bunch of logic gates and stuff, right? But I think the couple of main FPGAs that you're using to do as the BMC replacement, essentially, they have both, right? And you're kind of telling,
Yeah.
kind of interesting things, that you're doing some things in hardware or the logic gates, and some other things you're using the ARM cores and stuff. What's that experience been like in terms of splitting that up? Did you have to do a lot of constant thinking, or architecting so as to what should sit where? If someone wanted to improve on what you've done, or improve the design on what they've done, I mean, what kind of tools would they use to kind of extend some of this? Because this is something that's different, I think, or that people would find it
Yeah.
different compared to. Yeah, go ahead.
I mean, the FPGA tools themselves these days are pretty kind of graphical. It's kind of gone away from the days of old where it was all text, VHDL, Verilog. You can pretty much program one of these Zincs and UltraZyncs in a very kind of point and click manner, where you just place blocks of IP. So if you want a serial port, there's a big list, and you can just pick serial port, put in 16 serial ports, and then wire them all up together, things like that. And then it handles the kind of the translation from the hardware side to the software side. So it will generate you the memory map. It will generate you the kind of middle layer, which does all the mapping and tells Linux what device drivers to use. So it builds you a device tree and things like that. If you want to do sort of more exotic things, you're in the realms of still having to to kind of do proper FPGA programming. So if you've got things like custom PWM requirements, but again, it'll be a case of you do it once and then you just put the blocks in one after another. If you want 4 PWMs, just put 4 copies of the block in, wire them up, and away you go. So they've made it really, really easy to sort of just add more stuff.
So
Brilliant.
Adi,
Yeah.
in terms of potential applications for this outside of our project, what you have here is there's an off-the-shelf set of boards from Avnet that are dev boards. I believe the boards themselves are open source.
Yeah, but there's full schematics and layout available for the boards. I think they even provide you with an example layout of how to add the board to your existing system. It's really kind of geared up for it.
Then you've then got this chip on the board that has ARM cores, RAM, boots, Linux, runs OpenBMC, but attached to that chip, connected to your I/O pins on the board, is this FPGA that basically makes it so that you've got a point and click setup for that FPGA to set up what those different ports can do. So if you end up with something where, as Mark says, you need a whole load of I2Cs or lots of different interfaces to different devices, you can just program the FPGA to handle that. If you end up with something that is completely obscure and irregular that you need to handle, you can put code in the FPGA to handle that as well. But that could be proprietary code you have to write. How many nodes have we got now to support, Mark? What's the max node count?
In theory, it should support 16 as it stands at the moment. It's not been tested because we don't have a carrier currently to support 16, but it's the current design has 32 serial ports in it. It has Ethernet to JTAG, 2 copies of Ethernet to JTAG. It's also got 2 I2C interfaces and also 2 Ethernets. And that's the current kind of development side of it, and that's getting more stuff added to it as we go on.
Does that help, Adi?
No, it absolutely helps. I mean, it's actually pretty fascinating that you guys have gone this road and kind of figured it out and actually made progress too. It's not just something on paper anymore. So yeah, it's just brilliant. I mean, I'm just wrapping my head around it, how more people can use it, how it can be kind of like can reach more people essentially in terms of touch more people and they can take advantage of it. And yeah, I'll share some inputs in maybe in a little bit today, or maybe when I've had a little bit more time to think about it. But this is good. This is great. Keep going.
Do you have any more slides, Mark?
Just this final one, basically. So we've forked the existing Facebook OpenBMC with our own branch, and it's currently up on GitHub. It's got the track 1 system on it does build and does work on our carrier. The track 2 is still very much in development, and it's very much ongoing, but it's there currently, and some of the packages and some of the bits to help you integrate it with custom systems. You can take it away and play with it.
Cool. This is brilliant. And I think, from like just, being a little bit selfish and thinking from this project's perspective, Steven's been working on, getting some surveys out and trying to understand telemetry requirements and things like that. And it would be kind of fun to look at, what something like this approach would give someone who's building out a new system if they take something like an approach like this versus something that OCP is kind of like, say, something like what OCP is basically used to doing, basically using the AST chips or ASP chips or something like that. So if that gives us some extra capabilities, essentially, to get some of that monitoring that we are not able to do today in today's OCP systems, things like that. That would be an interesting thing to look at. and that would kind of help us push it to more people, or just kind of get it more visibility, and talk to people about its benefits and stuff.
So, Adi, I think in terms of what we have here, the system that's already up on the GitHub, someone can download that, put that on open source board today, and already have a tinker. It already works. The system we're working on will go on the high performing board, but the whole point with that is you have a board that may be a couple of $100, but that board can control probably sensor data points in the hundreds. And in terms of flexibility, infinitely flexible to handle proprietary and non-proprietary data input. That the idea could be for somebody with a low density installation, one of those boards with this software could probably do a whole cabinet for them. For somebody with a high density installation, multiple boards to handle every chassis or cubby or collection of nodes, one board for each. And then you could always plug in other proprietary signals into them that you need monitoring. So, both an upgrade in terms of firepower, but also adaptability, capability, and potential for adaptability.
So when I look at
go ahead.
So when I look at this, I'm digging into. I would like not to dig in, but I'm digging into my original assumption that if we continue to look at this in the context of the OCP Open Compute project, that we would need to think about perhaps the APIs that come to service are required for the liquid cooling piece, and then abstracting that would become specification for this group. The implementation itself is is in the right spot, and or with where the code is for it. The hardware could be a reference design coming through, no doubt, but the specification would need to be extracted, I think, for in an HPC view to as the contribution into this group, and then that would pave the way again for the reference platform. So I've changed my mind a little bit. We had talked about OCP products, we talked about inspired specifications, but there was a area for a reference platform. So maybe if we could get this a specification, and then have this be and then have the design be a reference platform design based off of the pedigree of the components that you listed, that would be a way to go.
Cool. Well, that sounds good. So I think as part of this work in progress, Steve, Mark's thinking about the API on the RESTful for all of the kind of liquid cooling related items, and certainly that could be something that could be interesting to think about. Mark, what are your timescales at the moment for sharing with the group?
The current sort of timescales are that we should be doing some more work on the track 1 stuff to support the actual compute elements when that carrier card comes back. So that's hopefully going to be in a couple of weeks, to just sort of finalize the track 1 system. And then the track 2 system will be the more R&D related one. So hopefully in a few months we should have sort of the initial coolant sensors integrated into that. We've got the coolant sensor hardware. We need to characterize it to kind of make sure it does what we think it will do, and then think about how we're going to present that information in the system, and how, of course, we kind of make it generic enough with different types of coolant sensors, different types of coolant information, can be presented, and then we'll sort of expand things from there. So
I think we've
hopefully,
got a lot of ambition, haven't we, around coolant sensors, and we've got a lot of things we want to work on in the future. Some that are solid, some that are vague, but so coolant sensors is certainly an interesting area. But I guess in terms of just the basic timescale for getting to something that somebody else could pick up and start using on the second board, the track 2, which is the more powerful Xilinx board, we're probably looking towards what, 3 to 4 months away. Do you think, Mark? Something like that?
I think that, because there's still some work to do on that, because it's a change from a 32-bit to a 64-bit processor on that board. The configuration is slightly different, so it's just getting all that sorted, and also getting the sort of reference side of the FPGA, the reference design for the FPGA side sorted.
Got it. I think that's fine. So we're looking at somewhere towards maybe a little bit, couple of months before the end of the year or something. And I think, at that point of time, what could be interesting is if we can take this and kind of like say, basically, port it to some other platform that's being newly built, or that's built but it's flexible enough or something like that, even if it's not super graceful. But I think if we can basically make sure it's interoperable towards the end of what you're trying to do, and that would be a good proof point for others who want to pick it up and use. So you've built it in as much of a modular fashion as you did, and then we've also tested it on something that's neutral, something that you didn't design it for essentially, or exactly, but people were able to do it, or port it or use it with that. And then it's just an argument that you can make maybe at the summit, maybe next year or something like that, that you can pretty much pick this up, and this is the approach you would go about it, if you want to kind of use it yourself or develop on the code that's there.
So I'm gonna refine that thought a little bit. One of the goals was here to discuss the goals of the community, and I think what you're saying is it's nice to see a reference design and perhaps the API stuff come forward. It would be nice to see if we could implement that reference design somewhere else, and I think that becomes bestowing upon us a little bit as the project leaders to try to make some connections here on where where this could be applied in other places. So I think we owe them some work in that respect, to socialize this around and see if we can help make that happen as a community goal. Is that fair?
That's fair.
Okay. All right, guys. I'm gonna and because I'm looking at the time here, let me. I think what we've accomplished so far is we've talked about potential directions here. I'm gonna ink in. I want to. We thank you for the pedigree and the views. So we've defined the IP at this point, and acknowledge that the timeline is 3 to 4 months for when we might be able to be mature enough from the project standpoint to abstract some of this or kind of submit what might be a reference design, if I got that correct. So let me pause there. Is anything I said objectionable? Okay. Then in that case, I want to open it up to the other people on the phone here. I know Adi and I have spoken a lot, but in order to make this a community conversation, Adi came in and said, hey, from a community perspective, we would like to see this reference design somewhere. My input, I guess, would have been that the API should come out of this so that we can, anybody else coming through here could say that they were compliant to the same interface or to the same interface standard, and define what that is. I'd like to see that as a result of this effort. Anybody else in the community have input to what they're seeing here, or have an opinion upon something that might derail this from being accepted, as it goes forward in these implementations that we're talking about?
Think it's
Okay.
just apart from us, I think David he's on the call. Um,
Well, that's okay. We'll type up minutes and we'll kind of send it out, and we'll recap it at the next project conversation.
Yep.
But what I want to make sure we cover this, because one of my goals here was to acknowledge the process. So if we're concluding with the community goals and the community input, let me go back to the process. I'm basically looking at the how to contribute steps off
Yep.
of the Open Compute page. And if you look at those, there's 5 steps, and the first step is, I'm not sure that we've done it yet, but it's also on the project lead checklist, is to sign a contribution license agreement. And maybe this is something that Peter can take a look at. I'll email it to you afterwards.
Yeah, I appreciate that, because I'm learning the process through this. I appreciate
No problem.
The reason for being here. Thanks.
Okay, so there's it's a license agreement, or there's a copyright license agreement, which pretty much is the premise for the legal premise for how the legal rights, what sharing constitutes. The second step is to present the project proposal or idea to the project group, and I consider this call and the paper presentation, both parts of that step. The third step is to write a spec, and there's a specification template, and there will probably be one for an API extension or for the reference architecture. They'd probably be separate, but there is a template for that. Of course, the first thing in the template says, have you signed the contribution license agreement, right? But I've created a shared document, Peter. I shared it with you, which is the template. It puts your contact information, talks about being your OCP membership, and then kind of outlines considerations to define what a reference design might be. And a lot of these were they talk about highly desired, but schematic placement. I mean, it gets down to
I think we've lost Steve.
Yep, I think we lost Steve. So it seems as though Stephen's actually working on basically understanding the process quite a bit, and kind of applying it maybe to this case. I mean, it's probably not very nice for you that this is our first contribution list after we've recently taken the project group up. But it's been done so many times now on other projects and this project before that. All that exists. We need to kind of talk to the right people, and kind of basically put it together. Yeah. I mean, not to kind of dumb it down, but when Rackspace had to do the Zay's Barrel IG2 contribution, it involved 2 things: getting a lot of people to sign the license because too many people contributed to the project, and then the second thing was to present it in a wide variety of places. But I think Steven's got more granular information than that, but that's at a high level, that's what it involved. Yeah, I think he's dialed back
yeah.
in.
I'm sorry. I'm sorry for that, guys. I really need a new phone. I went from a very expensive phone to a cheap phone, and I'm paying the price. So be careful. So I'll again, Peter and Nigel, I'll mail you this link, and so you can look at this, and we can start to talk about a checklist and how this would go. If you can get past the first step and get comfortable with that license agreement, we can go forward. Then the last step,
straightforward, right?
There is an incubation meeting, and there was just one yesterday, so I got to see a proposal go through. And that was enlightening. But that basically, if you take the presentation, that you gave, then break it down to what so you share the vision and what you can do with it, why it's important. But then take it down to the contributions themselves. You could probably get through the incubation committee, fairly in a fairly straightforward fashion. Now, they are nobody wants. In terms of like a API or a specification, everybody wants the ability in the community to participate. So there may be some questions with some competitive vendors to make sure that it's open enough for them to participate. And if you don't get that in our committee meeting or at the conference, you may get it at the incubation committee. But in general, the ones that went through yesterday, no one stood up except to ask a few questions, but that went pretty cleanly. At that point, if you were able to put a product out the door that implements the reference design, then you have the availability to use OCP Marketplace as a channel, and that would be your next step. Would be to fill out the appropriate work so that channel can work for you, and there's some marketing implications and other benefits that you would get if you get all the way to step 5. So that becomes a value proposition and some motivation. Okay, I'm getting a lot of static on the line. It might be my bad phone, but did we communicate the 5 steps?
Yeah, we got that, Steve. Thanks for that.
Okay.
So, Nigel, do you kind of understand this?
Yeah, I think, Steve, you did communicate it quite clearly. We just need to digest it and then work out how we can apply it to ourselves.
Yeah, I think one thing to be fair here, Steve, is we're still trying to figure out the basis of our interaction and what we want out of OCP. So as part of this process, we're also quite new. Just like you guys are quite new to the process as well. So I think as part of that, I hope we're all going to be very patient with each other.
Oh, I'm not. I'm very patient. I'm excited to have something in progress here, and are you going to the regional summit?
Yes, I've been asked to present at the regional summit.
Sure. That's right, the presentation alone. So I think at the regional summit, you might come to understand more of the upside of the participation, and hopefully after that, it will raise in your thoughts on the amount of the risk and reward here to go forward. And as a project lead, I'm committed to helping that process. So you can count on some of my time. Okay.
Thanks, Steve.
Yep.
All right, then I have some emails to send out to clarify this. I'm going to go ahead and minute this meeting as part of the pipeline of our process, and to make sure that I'm clear with the incubation committee to say that our step 2 is concluded, and we'll wait until step 1 is concluded, I guess, to declare that. And then we'll start to think about next steps when we get together again. I think we should probably not, unless you guys want to try to bring this into the meeting, since our meetings are in the afternoon, maybe we have a meeting in a generic few weeks here to discuss whether you're comfortable with the API and reference design approach, or whether you want to counter propose, or do you want to wait on a longer timeline?
I think
that could be interesting. Like Peter, what you said kind of was interesting just before. I mean, it's totally. I mean, you're just being clear about it. I think was you said, what your expectations are about it. You're trying to figure that out as well. So I think, how you want to do it, how you want to split this up and contribute would also depend, I guess, what you want to get out of it.
And I think that's this is a good one because it's a trailblazer. It lets us understand what the options are. And even though when we go through this, some of those options might not be appropriate to this, they might be appropriate to other things in the future. So I would like to see if we can arrange a situation where Nigel, myself, and some of the OCP people get on a call. Maybe you guys, Addy and Steve, could join, and we can discuss what different options there are, and what the potential upside and of each options may be. And maybe that could be done at the regional summit, because by the time we're there, we're going to have a lot more of this figured out. We're going to be further down the timeline.
Yep. Yeah, I think
But it could be
yeah,
in the meantime
go
as
ahead.
well. It could be something we can do in the meantime as an alternative on the call. I'm going to have a chat with Nigel after this call, and we'll see if we can figure out a timeline for engagement.
Yep. I think Bill Carter, the CTO of OCP, he has a pretty good history, seeing all kinds of contributions, all kinds of companies contribute interesting things, and he's kind of has a kind of view of both sides. It would be interesting to get on a call with him and the community director, basically the foundation representatives and our IC rep, and Stephen and I and you guys, to kind of just discuss, just purely from what would be the best way to do it, so that it would benefit most people. That might be an interesting call to have. It might be just beyond the technical details of it. I think you've presented it today and this call's recorded. So we could use that as a basis for getting those guys on speed a little bit, and we can just directly start with that conversation, just jump right into the specifics. And that might be an interesting thing for all of us.
Right.
And so we can arrange that call to be had, and then going in, it'll be maybe offline through some email, we can shake up what we consider the different options that might be to feed that call. This doesn't need to be the end all, but at least we'll have a dartboard, so to speak, going into that call, and can ensure that the conversation delivers what you guys are expecting, or at least covers those topics, while hopefully the best brainstorm comes as a result of having the meeting. All right. Well, hey, thank you guys for coming and having this call with us, and thank you for David for representing the community here with Audie and I. I'll send you guys some email, and we'll go back and forth a little bit on email until we consider when we can schedule that next meeting. I did take down as a next step to arrange that OCP leadership meeting, but we'll use email to figure out when we're comfortable in doing that.
Okay.
Thanks, guys. Bye-bye.
All right. Thank you, everybody.
Thank you very much.
Thank you, guys.
Bye.
Thank you.
Bye.